But yeah, this lecture is more just for, I guess, maybe a little bit of personal interest for anybody who's curious about it. This is kind of a cool application of a lot of the crypto that we've learned to something that's very relevant today. So yeah, because it's optional, like it's not as much of a lecture, so to speak. So feel free to like interrupt me at any time or just like throw questions in the chat. This is more a fun chance for us to kind of look at a protocol and tear it apart a little bit. So yeah, I guess we'll just get started with what we're talking about here. So today we'll be talking about contact tracing, and not everybody, I guess, may know what that is. So the first question you might ask is, what exactly is that? And basically, contact tracing is just the identification of individuals who may have come into contact with an infected person. So when we're dealing with something, like an epidemic or a virus, what we want to do is, if anybody is diagnosed as positive with this virus, we want to be able to identify everybody who they've been in contact with for some amount of time. And then with that knowledge, we can perhaps go and contact those people. So the reason why it's important is that we can contact people who this diagnosed person has been in contact with, and those people can kind of be warned to do some sort of preemptive testing or quarantining early. So it's actually been proven in past pandemics to be a pretty effective strategy at stopping the spread of these types of viruses. Okay. So we actually did this, for instance, in the 2002, the SARS virus. This was done, and a few other epidemics that have occurred. We've done this historically, and this has been like a proven strategy. And traditionally, the way that we've done this is that health officials will just talk to infected individuals. So, you'll get a report back from the hospital, and they'll essentially just either talk to you in person or call you and, ask you where you've been and try to build kind of a model from that. But it's a very manual method, okay? They're basically just going out and talking to people. And some states have started to do that here. So for instance, California we have a few thousand people who are signed up as volunteers for contact tracing, and they're essentially like calling people who have been diagnosed as positive and trying to talk to them and see where they've been, and then contact the people who they might have been in contact with. And this has worked all right historically, but it's not really working for COVID. And the reason why is that essentially COVID is highly contagious, right? Much more so than we've seen with some past epidemics, at least in like our modern age. And so these older techniques of like manually calling people aren't really scaling. And so, like for instance, California is having a lot of trouble keeping up with everything going on because we just don't have enough volunteers to do it. And so what really comes with that is we need some way to automate tracing without violating people's privacy. So because this is spreading at such a higher rate, we need some way that we can kind of automate this, tracking of, who has been in contact with who. But obviously we want to do that in a way that's not violating people's privacy. And that's kind of where Apple and Google have, come into play, and a lot of other work in trying to figure out how we can do this contact tracing, using our smartphones or things like that, but in a way that, isn't violating people's privacy. Yeah, so any questions on just overall contact tracing, maybe some history on it? Yeah, any questions? Okay, so that kind of brings us to Apple and Google's protocol. And so both of these companies kind of teamed together to create a decentralized contact tracing tool. And again, with this idea that we want to automate this contact tracing. And so using this, users can determine if they were exposed to COVID-19 or someone who was diagnosed with COVID-19. And they designed this app with a lot of privacy and security considerations at its core, which is one reason why we're covering it, is because it will use a decent amount of cryptography in how they designed it. Can anyone maybe take a guess as to why these two companies in particular were the companies who kind of went about taking a stab at doing this type of protocol? Okay, yeah, Trevor says lots of data. Anyone else? Yeah. Ganesh said we have the smartphone market share. Yeah, both these are right. So obviously lots of data, and then along with that is that Google and Apple are the ones who are creating, by and large, the majority of smartphones. And so they did this protocol together so that it could easily integrate with smartphones that work on their current network. And so the way that this works is it uses Bluetooth technology. And the reason why is because we know that COVID-19, is generally transmitted through some close proximity, and Bluetooth has a shorter range. So at its max, it's going to be about 10 meters, though it'll usually be a little bit shorter than that. And so essentially, also, can you guys see this chat window? Do I have to keep moving this? Does this chat window right here? Do you see this on the screen share?
Yeah, we can see it, so you may have to move
Okay.
it.
Okay. Okay. Yeah. So if someone is in your Bluetooth range, there could have been some contact. So essentially, we use the fact that Bluetooth is rather short range to our advantage, because essentially, if you're too far away, you won't be able to make this Bluetooth connection. Yeah. And so, as I mentioned before, kind of privacy and security are core to this algorithm. And so maybe a question for you guys: why? What are some bad things you might see happening with an app that was doing contact tracing? What type of information could be leaked? What type of security things do we need to think about? Do people have any ideas? Okay. Yeah. Yeah. Ganesh said location. Yeah. Yeah. As well as it is. Yeah. So location is a big one, right? So a lot of people don't want their location being tracked all the time. Yeah. So essentially, we want to make sure that no one wants their some company being able to tell like every movement they take throughout the day. So we need to somehow do this in a way that we don't kind of track this location data, and then other people's health status. Yeah. So and we'll kind of maybe get to this a little bit later, but you know, we don't want to necessarily reveal who has COVID because that can, is some private information that might lead to some abuse in some cases. Uh, so we may not want to leak the exact identity of who actually has this. Yeah. Any other ideas? So those are both privacy things. Any ideas for security? Why we would care about security? What could a malicious user do? Maybe. So may not be as clear right now. Maybe we'll talk about it a bit later when we get to more stuff. Yeah, yeah. Okay, I did said falsely indicate that you may have been infected. Yeah. So it may not be, it may not be totally clear why someone might want to do this, but let's say someone wants to falsely create a pandemic somewhere, and somehow they could get some monetary gain out of that or something, or like falsely, indicate that they have COVID when they don't. Yeah, yeah. So basically, a malicious user could mess with these things, and we need to keep that in mind. So if a malicious user could stop all the diagnoses from being reported, then obviously the app is useless, right? But then also if they could, if they could also say that a bunch of people have it when they don't, that's also not very good. Yeah, exactly. So Trevor pointed out, they could try to sell things to help infected people. So there's maybe ways that you can try to, kind of play this app to have monetary gain. And so we want to make sure that, when we design this, it's not necessarily incredibly easy for someone to do these things. And it's actually really tricky. The security part is, in my opinion, much harder to do than the privacy part, especially in a decentralized manner. Okay, cool. So now, basically the way that this works is Apple and Google are providing some API that plug, any phone, Apple or Google phone can use. And essentially what governments or counties can do is they'll create some official app that they want to use, maybe that communicates with hospitals in the area, and then they can plug into this API and use it. Okay, and it's opt-in to install the app and opt-in to declare if you're diagnosed with COVID. And this will become important, as we'll see later. But yeah, that's essentially how the workload of this is supposed to work. And let's get to actually, how would this work? So maybe a toy idea of what might happen is Alice and Bob are going to meet each other for the first time. And let's say they have some 10-minute conversation, or you just happen to be in the same area for a few minutes. And their phones are going to do is they're going to exchange anonymous identifier beacons. And so we'll get into what these are essentially, but you can think about just like this random identifier. I'm going to send it to everybody in my area. And I'm going to change these random identifiers all the time. Okay? So essentially, if I'm near somebody, I'll receive this random identifier. It doesn't necessarily leak to their identity, but I'll store that identifier. And then let's say a few days later that Bob is positively diagnosed for COVID and enters this test result into the app. So let's say the app that they have is able to connect with their local hospital, and so they can get the diagnosis and are able to upload to the server that they were diagnosed. And then, after Bob is diagnosed, with his consent, the app will send this key, and we'll get to what this key is later. But with this, and we'll see what it does in a second, but basically he'll upload this key to a remote server to say, like, I was diagnosed with COVID, here's my key. And then after that, every phone, but in this example, Alice's phone, will periodically download all these keys from the server. So in particular, she's going to download that key that Bob uploaded, and that key will allow her to figure out that a match was found. So it will allow her to figure out that actually, this random identifier I have is connected with somebody who has COVID or who is diagnosed with COVID. Okay? So she'll see this notification on her phone, and it, depending on how the app is set up, it can give her some information on where she could maybe get tested, or where she can find more information. Yeah. Okay. So any questions on kind of the workflow of how this app is supposed to work? Or I could run through it again if people. Essentially for right now, what you can think about is just, we're going to broadcast this randomness, and then somehow we have some secret that if I get diagnosed, I can release this secret publicly, and people can figure out that randomness they received was associated with somebody who had COVID. Okay? So yeah, now we'll actually get to the cryptographic protocol itself. And so if you guys read the paper that's actually linked in the description, you have all the understanding to fully understand it. Like we've taught you everything you need to know. There's a few details that I'm not going to show just because they're kind of unnecessary for this presentation. But yeah, it's kind of cool that with all the things that you've learned, you could actually completely create this app from scratch. So let's go through this a little bit. So every 24-hour period, what the app will do is we're going to generate this thing called a temporary exposure key, okay, that I'm going to denote as TE key. Okay? And so the way that we generate this thing is we're going to use, so this CRNG stands for a cryptographic random number generator. So just a random number generator like we've talked about in class. So, and this 16 is just saying that it's 16 bytes. So I'm getting, a 128-bit key that's randomly generated. And I'm going to do this every 24-hour period. I'm going to generate this TE key, okay? And then I'm going to generate additionally this rolling proximity identifier key, okay? So this RPIK. And the way that I generate this is I take my temporary exposure key and I run it through a hash key derivation function. So if you remember, this is very similar to what we saw in the project, right? We take some master key and we kind of derive another key using some form of hash key derivation. And so using this TEK, we generate this RPIK, okay? And both of these are regenerated on every 24-hour period. And our phone, your phone will essentially store each of these for like the last 14 days or something. And you'll see why in a little bit. Okay, so you generate these keys every 24-hour period. And then every 10 minutes, so every 10-minute epoch, you're going to do the following. So you're going to generate what's called a rolling proximity identifier. And what that looks like is you're essentially taking this RPIK, so this rolling proximity identifier key, and then you're evaluating the AES block cipher on the time epoch. Okay? So every day we generate this rolling proximity identifier key, and then every 10 minutes we kind of encrypt the time epoch using this key. And so since we know that block ciphers are basically act like these pseudo-random permutations, and this RPIK is randomly generated, it should be the case that this rolling proximity identifier is pseudo-random. Okay, so it's just this random identifier. And then what we'll do is we'll transmit this RPI via Bluetooth to all phones nearby. So this RPI is like that randomness that I was talking about earlier. Okay. And so every 10 minutes, again, we're going to have a new RPI that should be indistinguishable. It should be random. So we shouldn't be able to like link one user's RPI from 10 minutes to the RPI of the next 10 minutes. Okay. Any questions on this? This is like basically the bulk of the protocol right here. Okay. So then what happens is, so every 10 minutes, we're going to transmit these things. And then for receiving, every time I receive some RPI, I'm going to store the RPI along with the day that I received this RPI on. And I'm just going to store those locally for, let's say, like 14 days or some amount of time. And if a user is diagnosed, what I'm going to do is the key that I give to the server is this temporary exposure key. Okay? So I'm going to give this temporary exposure key along with the day. And I'm going to do this for, let's say, like the past week or 2 weeks or something. So however long I think I might have been contagious, I'm going to release my keys for that period of time to the server. And so essentially what's happening is we have this diagnosis server. And so this is the server that's kind of receiving all these keys. So it's going to aggregate all these keys for a certain number of days. And then it's going to serve them to users periodically. So users will query it and download all the keys that were uploaded to it. And then if you'll notice, there's no like user identity or contact information being stored on the server. So essentially all the server sees are these keys being uploaded. Okay. So now what we're going to do is we need to check whether we came into contact with somebody, right? So periodically, I'm going to query the server and I'm going to download all the temporary exposure keys that have been associated with people who have been diagnosed. And so maybe now, if you guys want to pitch in, how would I be able to tell, given this temporary exposure key, how could I tell if I came into somebody who was diagnosed with COVID? Okay, so Jack said, couldn't that be a huge number of keys to comb through? So which key are you referring to here? Are you saying that there could just be a ton of the temporary exposure keys being uploaded to the server? Yeah. Okay, so this is actually getting to the reason why we have this single key that kind of generates everything else. So you can imagine maybe an even more naive version of the protocol where we upload all the RPIs for for all the period that we could have been sick, right? So that would be like a huge amount of bandwidth. So it's kind of this trade-off between privacy and then bandwidth, right? So if we really wanted to, we could have like one key that lasts for let's say all time, and we could just have that. Maybe it would result in less keys being downloaded, but it would also lead to some privacy leakage. So the reason why we have to upload so many things is that we want for each day, we want that day of keys to be unique for the user because that best protects their privacy. But you're right, it could be a lot of keys. It's a great question. So that's kind of one of the big considerations is we need to make sure that, and maybe something we'll talk about later, but you need to make sure that it's maybe not easy to upload your keys to the server or else you could do some sort of DOS attack. What if each user stores the infected RPI keys with less data? So you're, Mitchell, if I'm understanding you, are you saying that essentially we'd only download like part of the keys each time? Yeah, so that could be an optimization that you could do. And I don't think that violates security in any way. So I think that could, once again, I'm not sure if like in the specifics of the server, they would do something like that. I guess they would. My guess would be that you can query the server for specific days and download all the keys for those days. So yeah, I think what you're saying is probably what would be done in practice. Okay, so any more thoughts on how, if I'm given this temporary exposure key of someone else, how could I figure out if I came into contact with them? Okay, so basically the way that we would figure this out is pretty much just by walking through this process again. So we have some temporary exposure key of someone else, and using that information, we can derive the rolling proximity identifier key, right? Because that's just basically this HKDF on some publicly known information. So we can rederive the RPIK, and then using that, we can also rederive all the RPIs for that given day period. Okay? So if I'm given the temporary exposure key, I can regenerate every RPI of that user for that day. And then I can see if any of those RPIs match the ones that I've stored locally. And if they do, I know I came into contact with that person. Okay. Does that make sense to people? So essentially, to walk through this again, we regenerate every related RPI and check against stored adversarial pairs. And if a match is found, you've been in contact with somebody who has COVID or who is suspected of having COVID. Yeah, so wouldn't you need to know the time you came? So the key this temporary exposure key, I can generate the RPI for the entire day period, right? So as long as I can, or maybe I'm not understanding your question correctly. So if I've received some RPI at some time, and then okay, let me step back for a second. So locally, we store every RPI we've received and the day that we received it. Okay? And then using this temporary exposure key, we can generate all the RPIs for that day. And so, if we have seen one of those RPIs, it will be stored under that same day period. Does that answer your question? Cool. Any other questions on this? This is essentially the entire protocol right here. So after this, we'll talk a little bit about privacy and security. Okay, let's move on then. So let's maybe get to some security analysis. And this is hopefully a little bit more of a discussion where you guys can just kind of throw out ideas of how you would attack this. Because there still are some big problems with this protocol, as nice and clean as it may be. Okay, so I think we talked about this before. So kind of, what sensitive information are we worried about leaking? So we're kind of worried about this time location samples of each user. So we want to avoid that. And then we kind of want to also avoid identifying specifically who a user is and where they've been. Basically, we want to be able to figure out, did I come in contact with somebody, but maybe not their specific identity. So if you'll notice, just by looking at these two, at its surface, the protocol actually doesn't store location, or at least it doesn't seem to need to. And also, it doesn't seem to store any sort of identity, right? So just on the very surface level, it seems like this app may protect both of these things. But there are kind of some caveats to that. So maybe let's talk about it a bit. So one thing that's important to note is there's kind of a distinction between what a client app can see and what the user sees on the screen from an honest app. Okay. So for instance, when we're storing these RPIs, we said that the phone should just store the RPI in the day, and that it shouldn't store location or anything like that. But a malicious app maybe could actually store the location data. And so later, if somebody's diagnosed and I've stored this location data, I can actually see exactly where I met this person, right? So here we kind of have an example where maybe if I use the app a little bit differently, I might be able to violate some of these properties. Okay. Oops. Let's go back. So I guess maybe I'll pass the question off to you. So let's think about two different cases, right? There's either the case where I don't have COVID and I've just been collecting these RPIs and broadcasting them. And then there's a whole different case when I have declared COVID, right? So maybe for the first case, so when I haven't been diagnosed with COVID, I haven't released any of my temporary exposure keys. Uh, what information is leaked? Do we think that the time location data is leaked? Do we think that the identity of somebody is leaked? So assuming that I haven't been diagnosed and I've just been broadcasting my RPIs, is any of my privacy lost? What do you guys think? Or if you want to think about it, the second question that I would ask is, if I was diagnosed with COVID and I released my temporary exposure keys, what information might be leaked then? Or is there a chance for a privacy loss if I release my temporary exposure keys? Is the question clear? Do people want me to like run back through anything again? It's not necessarily an easy question, but I just want to know where you guys are all at. Okay, Ganesh said where you came into contact with the person, and which case are you talking about? The case where I've been diagnosed or the case where I haven't? Yeah, and how do you think that you could figure out where you came into contact with that person? So yeah, this kind of, yeah, no worries. This kind of goes back to what I was mentioning before, right? So in order to figure out where you came into contact, you'd have to have some sort of malicious app that stored the location as well as receiving the RPIs. So when you receive the RPIs from the people around you, you'd have to also store location data. And then if someone was diagnosed, it might, they might be able to figure out the location of where you came into contact with somebody. So, for instance, if you went to someone's, let's say their house, and so they were the only person that you saw, and then later, they were diagnosed, you might be able to tell like, oh, this was the person who was actually diagnosed because they were the only person that I saw in this area, right? Yeah, so that's definitely correct. Any other things that people can think of? So yeah, as Ganesh was kind of pointing out, there's this distinction between somebody who has been diagnosed and somebody who hasn't. So for some user who has been diagnosed, so Alice's client could figure out where the user was and where she met him. So kind of what we were just talking about. And then even more so, if a few users were to come together, they could reconstruct all the time location paths of bot. So if a few people collaborate and they've been around him for some period of time, they could totally figure out his time location path. And so what this means is essentially, if you are diagnosed with COVID and you release your keys, you kind of lose your privacy guarantees. So there's still a good chance you have privacy, but there's no guarantee of it, right? So you lose basically all those guarantees. However, if you haven't declared COVID, you could maybe track a user for 10 minutes, right? So if they moved, you could maybe receive the RPI in one place and then receive it in another place. But besides that, you can't really do much, right? Because after that 10-minute period, the RPI is regenerated, and there's no correlation between those two things because they're generated from a pseudo-random permutation. Okay, so essentially, if I don't declare COVID, then my privacy, I have pretty good guarantees for my privacy. But if I do declare, then I lose a lot of those guarantees. Okay. Does that make sense to people? Any questions on the distinction between these two? Okay. So how could you, so Ganesh asked, how could you track someone for 10 minutes? So the way that you could track somebody is, if you remember, every, I think it might have said 15 minutes, there might be a discrepancy there. Every 10, 15-ish minutes, you generate this RPI and you broadcast this RPI. So if I'm standing in one area and I broadcast the RPI and then I move somewhere else, my RPI in that other area, if it's within 10 minutes, would be the same. So I could tell that the same user has been in those two places. Does that make sense? Okay, cool. Okay. Yeah. So then, what does the server see? What's the effective? So Jack asked, what's the effective range of Bluetooth on phones? I believe technically it's 10 meters, so about 30 feet. If you have obstacles in the way, it might be less than that. So it might be a little bit more than we say like 6 to 10 feet, right? So the Bluetooth might be a little bit beyond when you come into contact with somebody. Okay, and then Mitchell asked, can the service be turned off when the user is at home so it doesn't result in false positives? So do you mean, by false positives, do you mean like if somebody was walking like outside? Is that what you mean, Mitchell? Yeah, I'm not sure actually. So that would probably depend on the app. And I'm assuming, you could probably just turn your Bluetooth off, right? And then the app won't work anymore because it requires Bluetooth to be on. That's a good question though. Yeah, it kind of requires this opt-in. So I'm sure, if you made this app, there would be ways to turn it off if you wanted to. Yeah. Okay. Yeah, great questions. Or smartphones in different units. Yeah. So maybe, yeah, I hadn't thought of that, but that's a good idea. If you were just at home, maybe you'd want to turn it off because you might get some false positives. Yeah, that kind of comes to more, especially on like the Bluetooth range, it's more of a hardware issue. I'm not sure if there's a way to like only broadcast it like a certain length, but I don't think that's the case. Yeah. So yeah, it is definitely the way that you design it. So for instance, if I broadcast like super frequently, I might get a lot more false positives. Yeah, because I might kind of just like briefly be in contact with somebody, but then not really. So I'm not entirely positive how they actually would go about dealing with that. But my guess is that they're more willing to have false positives than false negatives. Yeah, great questions. Cool. Anything more on this idea of just like the Bluetooth and false positives that people had? Okay, so maybe what does the server see? So the server, for users who have declared COVID, it sees their, their temporary exposure keys technically, and then it can derive, but essentially it sees their rolling identifiers. And so put together with location data, i.e. if it, collaborated with some users, it could also identify individuals. So essentially it could, in the same sense that other users could identify infected individuals, the server could as well. But for non-diagnosed people, it might know the number of users, when those users check for updates, and any other information that it gets maliciously. But besides that, it's not really seeing any other personal information. So the server doesn't really see much here. Okay. So what other attacks could there be? Do people have any other ideas for either attacks that a malicious user could do, or maybe a malicious server? Yeah, so Jack mentioned a DOS on the key server. Yeah, so if you were able to take down the key server, right, there's no way for people to download the keys and figure out, right? So if you were able to DOS that successfully, you could basically render the app completely useless. So that would be a threat. You'd have to make sure that the key server is pretty resilient. So when you say TIA key spoofing, do you mean just like generating like false temporary exposure keys? Yeah, so So that might work. If you remember, so we're using 128-bit keys. So even if I generate random ones, that might cause like maybe I missed. Are you saying in terms of like a denial of service attack? Because yeah, one way that maybe a denial of service attack could work is I could upload a bunch of temporary exposure keys. Of course, that depends on the app, right? So you might have an app that would only allow you to upload to the server if the hospital certifies it. So that's kind of at an application level. Yeah. So yeah, it kind of depends how you design the app, but a malicious app could totally do that. And I don't think there's really any way that you could stop that unless it's kind of how you design the application. I don't know, between users and the key server to frame. So Mitchell said, a man in the middle between users and the key server to frame someone else as infected. So how would you frame somebody? Maybe I'm not seeing that one as much. Do you want to explain a little bit more what you mean? Yeah, so the key here, so Mitchell said by posting other keys. So I'm not sure how, so we only release keys if we're diagnosed, right? So if we aren't diagnosed, these keys are going to stay private on our phone. So I'm not sure. So, and if you remember, these keys are randomly generated and they're 128 bits. So it would be computationally infeasible for us to like guess the key of some user and frame them. But that's you're kind of on track of a different problem that might happen. I don't know if you or anyone else can see it. Yeah, so if the key doesn't exist, then users would download it. They generate all these RPIs, and because it didn't exist with very high probability, it just wouldn't match any of the RPIs that they had received for that day. So yeah, kind of in line with the denial of service attack, I could upload a bunch of spoofed keys and it would act like a denial of service, but because we're working in a big enough space, it would be really unlikely that it would like accidentally frame somebody if they didn't have it. And that's just, if you remember the properties of like, we're randomly generating these keys and we're using these pseudo-random permutations. So, we're in a pretty big enough space that, it's like 2 to the 128 is the probability that we have, a collision between these. Yeah, great ideas. Any other thoughts on attacks that can happen? Yeah. So 2 to the 128 is very big. So you could definitely store whole populations keys, and like for a long time, and you would probably be fine. Yeah. Okay, so maybe I'll just go through some of the attacks. So one thing that you could do is you could install a recording device in many places, right? So I could go to a city and I could record, or I could put a bunch of Bluetooth devices that kind of track, all the RPIs in those areas. And then what I could do is using those, I could kind of reconstruct the identity and paths of users who actually declared COVID. So I could kind of act like multiple users at once and kind of track where people have been going, right? And so if I, maybe I put this in a residential area or something, and I can track a single user's like all their movement throughout the city because I have enough of these recording devices. So that's pretty scary. So that's one possible attack that people could do. As we mentioned, we could do some sort of denial of service. So actually a little bit different than, I think, who was it who mentioned this? Than as Jack said. So instead of just doing a denial of service on the key server, maybe what I could do is I could go, somehow get a bunch of Bluetooth devices and just broadcast a ton of RPIs, right? And all the users' phones have to store these RPIs. And so if I could just generate a bunch of random RPIs and broadcast them, I might be able to somehow denial of service the app. Either it would run out of space or, so that's another possibility for what we could do. And we could also do some sort of replay attack. So, I could put, a Bluetooth receiver in one city and then a broadcaster in another city and kind of replay everybody's RPIs through these receivers. And then what could happen is that if one person is diagnosed in one city, I could kind of create like a fake breakout in a whole another city. I think we were kind of thinking of this earlier as to why we need security, right? So I mentioned before that security is kind of hard to get with this app. Because we're just broadcasting randomness to protect identities, that randomness can kind of be replayed somewhere else, and there's not really much we can do. So in order to solve these problems, it definitely takes a much more heavyweight cryptography, I would call it. That's a bit beyond the scope of this class. But a lot of work has been kind of exploring like how we would stop these attacks. Do these make sense? Do people have any questions or any ideas on different attacks or variations of these attacks that we could do? Yeah. So Mitchell said we could sign the random identifiers to stop spoofing attacks, but that would breach privacy. Yeah. So it's actually an interesting idea. So yeah. So the problem with that is that in order to actually release, let's say let's see, does that actually solve the problem though? So if you sign this random identifier and you just replay the random identifier with the signature, you can still replay that, right? So unless what you could maybe do is you could somehow put like the location, like you could say a very like vague location like California and then sign that, right? And so if someone tried to broadcast that in like Singapore or something, then it wouldn't be accepted. But you'd be having to leak some amount of your location, and also you'd be leaking your identity, unless you figured out I mean, at this point, you'd have to have some sort of public key infrastructure, and then your app becomes much more complicated, right? But that's an interesting idea, and there have been works that have explored exactly that type of thing. Any other ideas or thoughts? Okay. So yeah, so kind of because of what we've talked about, so users might be afraid to declare COVID, and kind of in terms of the identity level of things. So there have been cases of people being mistreated or having violence committed against them for having this virus, and in particular, if someone caught it and then spread it to somebody else, people might be angry, they might hold grudges, and so this is generally why we're worried about protecting the identity of people who might actually catch it. And then also, I think we touched on this a little bit, but a malicious server could kind of affect the correctness of this tracing. So kind of in line, we talked about how a denial of service against the server would take it down. And in the same sense, a malicious server would ruin the entire protocol as well. And then we've talked a little bit about some of these. So what can a malicious user do? So they can create false positives. They could upload, these fake COVID diagnoses. So maybe one attack, I could broadcast, my RPI in a bunch of different cities and then say I have COVID. And if the app doesn't, properly check for that verification, I could create basically false breakouts. Yeah, and then we talked about the replay attacks and stuff. Yeah, so we cannot prevent the honest user of COVID to upload their own diagnosis unless the attacker can somehow jam the network. So it is pretty hard for us to like actually, I think at the very beginning, someone mentioned we could block users from uploading their diagnosis. And this would kind of be maybe a denial of service on the key server. Actually blocking the users would be hard. So most likely the way you'd want to go about that is somehow doing a DOS against the diagnosis server. Okay. So kind of, I guess, in summary, we talked a little bit about how contact tracing is really crucial for controlling the spread of the virus. Public health officials have talked about this for a while, and we've used it in past pandemics. And so we've introduced, this new contact tracing protocol because we need to be able to automate this process. Like old techniques aren't really scaling well enough, but we also need to protect privacy. And for what we've seen from just this very, somewhat simple app that we can all understand, people who, don't get diagnosed have a pretty decent guarantee of privacy, but those who actually do get diagnosed lose a lot of the guarantees of privacy. And actually, in terms of when I was researching this to see if it was used, it's being used in like a few select places, but generally it seems that just unfamiliarity with the technology has really hampered adoption. So a lot of these public health officials are used to these old ways of doing things, and the technology kind of intimidates them. They don't know, how to actually implement it, or they don't understand it. So this is kind of another example of the explainability of our technology as computer scientists becomes really important, because in order for this stuff to be used, we have to be able to explain it to people in a way that they can understand, in a way that they can actually implement.